Welcome to ClickMyProject.com. Now we are going to discuss about deep learning for screening of interstitial lung disease patterns in high resolution CT images. To develop a screening tool for detection of interstitial lung disease pattern using deep learning method, a fully convolution network was used for semantic segmentation of several ILD patterns. Improved segmentation of ILD patterns was achieved using multi-scale and feature extraction. Dilated convolution was used to maintain the resolution of feature maps and to enlarge the respective field. This project introduces an end-to-end deep convolution neural network for classifying ILD patterns. The proposed model comprises sparse autoencoder decoder with convolution neural network and BGC16 and resonant 50 activation function, followed by the batch normalization and max pooling with a size equal to the final feature map size as well as 4 dense layers. This is our project flow diagram. We have 5 modules in our process. First module is a data selection and loading. Data selection and loading is the first process where we are going to select our data as CT images for this process, and then data pre-processing. Data pre-processing means cleaning the data set. Here we have images as a data, so we are going to resize the images and scale into the normal channels. And then a third module is a data splitting. Here we are going to split our data into training data and a testing set. Training data is to train our model, and the testing data is for prediction purpose. And next one is a classification, that is algorithm implementation. Here we have used sparse stack autoencoder decoder with convolution neural network and BGC16 and resonant 50 activation functions. At last we are going to see the performance analysis and the report generation of our process. Here we are going to see the reports as a graph between the validation and original input, and then we are going to check the accuracy of each algorithm. After that we are going to see the confusion matrix, that is true positive, true negative, false positive, false negative values of the data. At last we are going to predict by selecting an input image, we are going to detect whether it is affected by the cancer or not. Now we are going to discuss about our project output. Our first module is the data selection and loading. Our data are in the format of images, and in that data we have two categories. One is cancer and another one is a normal. Our first module is a selection of our data set and a loading to our process. First we are going to check about the minimum height, maximum height, and minimum width and maximum width of both category cancer and normal. And second module is the data pre-processing. Data pre-processing means cleaning our data set. As we have images as our data, we are going to resize all images into the same size, and then we are going to channelize all the image into the same channel. This is the sample input after the pre-processing. And then data splitting. Here we are going to split our data into training set and testing set. Training set is to train our model, and the testing set is for validation purpose. After that we are going to implement the algorithm. First we are going to see about the sparse autoencoder and the decoder. The sparse autoencoder consists of two parts. One is encoding and decoding. The encoder compresses the data from high dimensional space to low dimensional space, and then while decoder does the opposite, that is it converts the latent space back into the higher dimensional space. This is the encoding part and this is the decoding part. After that we are going to summarize the sparse autoencoder decoder, and then we are going to check the total number of trainable parameters and the total number of non-trainable parameters. This is the running time taken for train our model, and then this is the accuracy of CNN, and then this is the performance of graph between the loss and accuracy. And then it is a classification report for the sparse autoencoder and the decoder, and then confusion matrix, and then BGC16. BGC16 means it is also convolution neural net architecture that is used for image recognition. It utilizes the 16 layer with the weights and considered one of the best vision for model architecture. These are all the layers, 16 layers which are used to train our data. And then this is the summary report, and we are going to check the total number of trainable parameters and non-trainable parameters. And then we are going to check the classification report and the confusion matrix for the VG16 also. After that, ResNet 50. ResNet 50 is a convolutional neural network that has 50 layers of deep. We can load our pre-trained version of the neural network and train more than 1 million of images for the ImageNet database. And this is the summary report of the ResNet 50. Here we have 57,728 data which are non-trainable parameters, and then we are going to see the accuracy graph between the loss, and then we are also going to check the classification report and the confusion matrix for the ResNet 50 also. At last, prediction. This is the prediction model. Here we are going to select our own data as a input from our trained model, and then we are going to check whether it is in the category of cancer or normal. Thank you.